The force of one of these space rocks equals 10,000 Hiroshima bombs, as the power contained within this piece of genuine domain spans a mile across. Oumuamua, a baffling substance that once traversed our nearby planet group, has again sent shockwaves throughout the scientific community. Elon Musk, a prominent pioneer in space technology, revealed that Oumuamua is back, and this time it's not alone in its journey. Elon Musk claims that its mysterious attributes contain an enticing clue regarding life in other star systems. This isn't the ordinary return of a divine element. It's a return that challenges our understanding of space and its true potential. Join us as we unravel the implications and secrets surrounding Oumuamua's startling return. Back in 1837, a mysterious object reached a remarkable milestone. It crossed a distance of 1,000 cosmic units from the Sun. For over a century, this object continued its journey inconspicuously, steadily progressing towards our star. It was only after October 19, 2017, that humanity finally became aware of its presence. On that particular day, an image captured by the Pan-STARRS 1 telescope at the University of Hawaii revealed a faint, delicate streak traversing the sky at a consistent speed, covering around 6.2 degrees every day. This marked a historic moment, the first recorded interstellar visitor officially designated as 1I/2017 U1. This object was also given the name Oumuamua, which means a courier from afar arriving first in Hawaiian. The discovery initiated a global drive to observe Oumuamua through telescopes. Astronomers, including those from the SETI Institute, enthusiastically engaged in observing the object, even sending out searches for possible extraterrestrial signals. Oumuamua resembled a reddish, cigar-shaped object comprised of rock. Its elongated shape is striking, stretching up to 1/4 of a mile long and about 10 times longer than it is wide. Oumuamua has an aspect ratio that surpasses any asteroid or comet seen in our solar system. Its elongated shape is highly unusual and unlike anything we've seen before. Oumuamua was traveling at a speed of 196,000 miles per hour when it approached Earth, which is 5 times faster than a bullet, meaning there is no way that this object was part of our nearby planet group. This time, scientists couldn't initially determine if Oumuamua was an asteroid or a comet. So what's the difference between the two? Comets are composed of ice, while asteroids are rock. Initially, scientists thought it was a comet, but their classification changed to considering it an asteroid once it dashed past the Sun on September 9, 2017. However, they still considered it as an asteroid until additional measurements showed slight acceleration, which is a sign of it being a comet. But the fact that Oumuamua sped up much more than we anticipated puzzled scientists for years. A significant characteristic of Oumuamua was its periodic brightening and darkening every 7.3 hours. This dynamic behavior indicated its rotation around its short axis. Such a rotation pattern suggested a more rigid and durable composition than the typically soft, snow-like material of most comets. Appearing dark red like certain moons in the outer planetary system influenced by space radiation, Oumuamua's color could also include iron, as suggested by Dr. Meinl, an astronomer at the University of Hawaii. However, despite these insights, Oumuamua's origin and nature remain a mystery. This trajectory puzzled scientists, indicating something beyond ordinary explanations. Various theories emerged to figure out Oumuamua's identity. While some believed it to be a rock, others suggested it was made of gas. Incredibly, a subset of researchers even entertained the possibility that it could be an extraterrestrial space apparatus. This raises the intriguing question: could an extraterrestrial mothership be exploring our solar system and deploying smaller probes to explore planets? In the subsequent section of this video, we will delve deeper into these mysteries. But first, let's examine the range of scientific implications that have been put forward to interpret the origin of Oumuamua. Dr. Meinl proposed the idea that it could have been flung out from a distant star following a cosmic explosion or perhaps formed when two objects collided and merged. Initially, astronomers were excited when they observed that the trajectory seemed to point towards Vega, the brightest star in the Lyra star cluster, known to have a debris disk. Calculations showed that this object might have traveled from Vega to our location in roughly 600,000 years. However, the likelihood of Vega being the actual source has diminished due to significant changes in its trajectory. It's believed that Oumuamua encountered a new star system for the first time, considering its motion around the Sun, which was similar to the speed of neighboring stars. However, there's a possibility, as suggested in nature, that Oumuamua could have been traversing around the system for billions of years. We're uncertain about its upcoming trajectory. Imagine it like this: remember how the Voyager spacecraft gained a boost in speed from Jupiter? Well, Oumuamua is also gaining speed from the Sun, propelling it faster and in a different direction. Dr. Meinl explained that this asteroid, along with its counterparts, alters our view of the galaxy. Picture this: when you look up at stars seeming distant and isolated, it contrasts with what these asteroids reveal. They remind us that things are interconnected and fascinating. The oxygen and iron inside our blood emerged from a massive supernova explosion in a distant place long ago. Shiny objects like wedding rings resulted from the collision of superdense stars, and those shooting stars falling to Earth. Some of them originated from Mars due to asteroid influences. Remarkably, some respected scientists speculate that these shooting stars might have carried life from Mars to Earth during a time when Mars enjoyed warm and wet conditions. Life could have begun there and then hitched a ride on those shooting stars to Earth. It's a daring idea, but it's being considered by respected astronomers. Our connection to the universe can be traced much further back in time. Consider the millions of years Oumuamua could have taken to appear here. While that may seem extensive, it's just a fleeting moment on the astronomical scale. The Milky Way galaxy boasts an age 10 billion years over this massive time span. Oumuamua could have traveled through approximately 20,000 star systems, a modest fraction compared to the galaxy's 200 billion stars, yet still countless cosmic journeys. Oumuamua would have trailed behind dust and debris, allowing the stars and the worlds of the system to intermix. This suggests that the universe may be smaller in scope than previously thought. Even if it's no longer within our immediate view, the nearby planet group hasn't abandoned it just yet. Elon Musk and other cosmologists anticipate that Oumuamua will enter the Kuiper Belt around 2024 and cross its edge by late 2025. He also estimates that it will pass Jupiter's most distant point in 2038. Although our Oort cloud is predicted to extend beyond 100,000 astronomical units, AU, by 2196, it will still be a distance of 1,000 Australian dollars from the Sun. Thus, the exact moment when Oumuamua actually departs our planetary system depends on how one defines its limit. However, since Oumuamua has been distant for astronomers, they are making the most of the information gathered in just a few months to understand as much as possible about this intriguing interstellar interloper. Initially confused with an asteroid due to its size of around 2,600 feet long and 260 feet in width, Oumuamua exhibited peculiar behavior in its trajectory. Space experts and researchers noticed an outstanding non-gravitational acceleration indicating that forces beyond gravity were influencing its movement. Dr. Meinl figured that several factors could lead to this acceleration. Her team analyzed at least 6 potential causes, eliminating some due to their improbability or inconsistency with observations. One likely explanation was comet outgassing, a common occurrence in comets. Outgassing happens when a comet approaches the Sun, and its surface ice sublimates directly from solid to gas. This process gives the comet an extra push, altering its speed and trajectory beyond gravitational influence. This change in motion resembles the behavior of Oumuamua, aligning with the force observed in comets. Notably, the lack of ejected dust from Oumuamua was fascinating. Typically, as gas leaves a comet, it carries surface dust with it. However, Dr. Meinl asserts that even if the comet lacked minute material, the likely presence of significant dust on its surface could have been affecting its speed, keeping its possibility of being a comet alive. Moreover, scientists primarily examine visible frequencies, which make it challenging to detect large dust particles. Thus, no apparent evidence of dust leaving Oumuamua was observed. The absence of gas-related signals was also surprising. Surprisingly, astronomers expected a noticeable amount of gas emission to influence Oumuamua's speed in the way seen. Despite their efforts, no CN gas was detected within their detection limits. Considering that comets in our planetary system can hold significant amounts of water, Areas of strength for the limit set by the lack of CN gas indicated that this comet was chemically unique. According to Meinl, it's a bit challenging to infer much from what you don't know. But again, it doesn't seem to act like a standard comet. Considering that Oumuamua hailed from a different planetary system, these abnormalities could be typical of objects originating from other star systems. The trajectory of Oumuamua was meticulously traced back to before its initial entry into our planetary system by Corin Baylor-Jones from the Max Planck Institute for Astronomy. Comparing this trajectory with the past positions of 7 million stars tracked by the Gaia satellite, Baylor-Jones rewound both Oumuamua and the star's orbits to identify potential points of intersection with the stars with trajectories that approached close enough to Oumuamua's rewound path. Four candidates stood out as possible origins for its home. Elon Musk claims that Oumuamua's trajectory had crossed within a range of 1 to 2 Oort cloud radii or 100,000 to 200,000 astronomical units, AU. However, as often troubles arose, the encounter speeds of these candidates were relatively high, ranging from about 6 to 16 meters per second, a potential complication. Oumuamua is likely a planetesimal, a form cast out during the formation of planets. It's rare for planetesimals to achieve ejection speeds this high solely through interactions with massive planets. Our expectations would have suggested speeds of just a few miles per second. While these speeds are high, they are certainly feasible but highly unlikely. The scenario becomes more plausible if Oumuamua originated in a binary star system. However, none of the candidates were recognized as binary stars. Pending data releases from the Gaia mission could help astronomers in identifying a more plausible source for Oumuamua by providing deeper insights into the motions of nearby stars. In a few years, it would be intriguing to revisit this. The first and so far only extraterrestrial visitor we've observed traversing our solar system remains Oumuamua. Despite its mysterious nature, experts worldwide are fascinated by its true potential and secrets. Indeed, Oumuamua continues to captivate due to its unique attributes. Now it appears Oumuamua isn't alone. Back on August 30, 2019, Gennady Borisov, an amateur astronomer at the Margot Observatory in Crimea, identified a new comet named 2I/Borisov. This comet was hurtling through space at a staggering velocity of 93,000 miles per hour, faster than what you'd expect for an object positioned around 2 astronomical units, AU, away from the Sun. What caught our attention, other than its speed, was its trajectory. It was plunging into the interplanetary system at an angle of 40 degrees relative to the ecliptic plane, on an orbit marked by an extreme high eccentricity of 3.7. This indicated that, like Oumuamua, Borisov also had an extrasolar origin. Unmistakable from Oumuamua, Borisov exhibited a clear comet-like appearance, making it a reddish-tinted traveler that aligns more with our conventional understanding of comets in the nearby planet group. This uniqueness highlights the diversity in interstellar objects. Such differences are invaluable for astronomers striving to understand the processes shaping other solar systems, whether similar or distinct from our own. This ongoing exploration expands our perspective on the broader universe. Meanwhile, some astronomers have dared to suggest that Oumuamua may be of extraterrestrial origin, adding to the intrigue. A draft paper by a Harvard scientist and the head of the Pentagon's UFO office suggested the possibility of an extraterrestrial mothership within the nearby planet group, dispatching minute probes similar to dandelion seeds to explore the planets. The revelation of this document came from Sean M. Kirkpatrick, the head of the Pentagon's Anomaly Resolution Office, AO, outlined in July 2022 by the Department of Defense, DoD, to identify and investigate anomalous objects. Collaborating on this draft, focusing on nearby the DoD was Avi Loeb, an astronomer at Harvard University. However, it's important to note that the paper is not an official Pentagon document. Loeb is renowned for his research on Oumuamua, having even proposed the idea that Oumuamua may be an extraterrestrial spacecraft 6 months before Oumuamua's close approach to Earth. A small interstellar meteor, roughly 3 feet in diameter, struck our planet. Although irrelevant to Oumuamua, this meteor, known as 1I/2022 C1, caught Loeb's attention. By chance, Loeb considered the possibility that an artificial interstellar object could act as a parent craft, releasing multiple small probes during its passage near Earth. a concept similar to NASA's spacecraft missions. In their draft study, Loeb and Kirkpatrick delved into unidentified aerial peculiarities, UAPs, a term preferred by the government for UFOs while adhering to established physics. The scientists speculated that the dandelion seed probes could travel to Earth for observation without being detectable by survey telescopes, likely due to their small size. According to their proposal, the technology of these probes could enable them to slow down in Earth's atmosphere to prevent burning up, then utilizing their parachute-like mechanisms to navigate to their intended destinations after landing. That's what scientific speculation suggests extraterrestrial civilizations might aspire to do: focus on rocky planets with atmospheres within our planetary system. Planets like Venus, Earth, and Mars would undoubtedly pique their interest after detecting signs of liquid water. The mothership wouldn't necessarily need to be home to the advanced extraterrestrial civilization that created the probes. The possibility of the mothership communicating with these probes is also debatable. The idea that a habitable planet with intelligent life could have dispatched probes long before Earth existed is an intriguing proposition. Loeb compares it to occasionally checking our mailbox for accumulated packages, even if the senders are no longer around. Loeb has faced skepticism from the scientific community since he first proposed the idea that Oumuamua could be an extraterrestrial spacecraft. Some critics view his theory as provocative and lacking a solid foundation. In 2021, a letter published in the journal Astronomy and Astrophysics refuted the feasibility of interstellar travel, citing cosmological timescales required to cross between stars. The authors concluded that it's implausible Oumuamua was sent by an extraterrestrial civilization, more reasonably ascribing it to an oddly shaped rock that happened to wander into our planetary system. Another study has indeed debunked the idea that Oumuamua's mysterious movements could be attributed to an extraterrestrial spaceship. Instead, it offers a plausible explanation suggesting hydrogen off-gassing, which occurred on March 22, 2023, as the likely cause behind the unconventional behavior. However, recent times have seen the Pentagon renewing its focus on investigating anomalous aerial phenomena within American airspace. Since last summer, the Anomaly Resolution Office, AO, has initiated over 360 additional inquiries into reported encounters with unidentified aerial phenomena, UAPs, by U.S. military personnel. Around half of these cases have been attributed to balloons or similar objects, while the remaining half lack sufficient data for a definitive determination. In the quest for understanding, figures like Elon Musk hold hope that advanced telescopic surveys could unveil more extraterrestrial objects. These discoveries could provide valuable opportunities for scientists to put their hypotheses to the test. The parallels with exoplanet discovery offer an encouraging precedent for such endeavors. Just 20 years ago, the first exoplanets beyond our nearby planet group were discovered. In just 20 years, our understanding has expanded decisively, confirming the existence of over 4,500 exoplanets. This progress highlights the rapid advancement made in the realm of astronomical research.